Anyway, good afternoon. My name is John Mankins. Welcome to this solar power satellite session, which has been organized under the auspices of the Sunset Energy Council with the National Space Society. In a few moments, we're going to begin a relatively brief but interesting session concerning solar power satellites, including a series of presentations on both the technical aspects and the rationale for energy from space, and some discussion of the approaches thereto. We're going to begin with a presentation by Darrel Preble, who is the you've got your program, but not your presentation. Who is the chairman of the Space Solar Power Workshop. And with that, Darrel Preble.
Thank you. Glad to be with you. My talks are broken into two sections: the why for space solar power and the how for space solar power. And let's see if there's something we can turn pages with.
Page up, page down.
For the last, decades, since Roger Revelle first noticed and inaugurated CO2 rising measurements, thousands of scientists have been struggling to understand the changes going on in our climate and our environment. Meanwhile, other important changes have been taking place in our energy picture, most notably oil right now. All of these have an important voice which should and ought to be heard in Washington to impact the inauguration of space solar power. We're going to review briefly all of these areas. If you'd like to go into greater depth on the Space Solar Power Workshop page at Georgia Tech, you'll find exhaustive references backing up what I'm going to cover. I can give you arrow over, arrow down.
You put the cursor in the little bar on the right hand side.
Well, all right, yes, we'll try that. That's a good idea. This is a bird flu kill. Now, the gathering global storm, which we are in the middle of, as I just mentioned, involves these areas. And the first one we're going to talk about in a little bit of depth is oil. I don't know how many of you have been following on the technical level with the peak oil arguments, but I would encourage you just to take a look at those. We're going to look at these briefly. There were hearings in Congress in December on peak oil, most notably on where we are and how we can respond. A study done by the United States Corps of Engineers states that world oil production is at or near peak, and current world demand exceeds the supply. Saudi Arabia, the bellwether for global oil production, has not been able to increase production in the last 3 years. From the same source, United States Army Corps of Engineers, once worldwide petroleum production peaks, geopolitics and market economics will result in even more significant price increases and security risks. Oil wars are not out of the question. I was reading a quote from the Iranian oil minister yesterday, who was figuratively rubbing his hands saying, I think we may have $100 oil this summer. It's possible. Matthew Simmons is the president of the world's largest energy investment bank. Basically, we've used up the majority of the world's high flow rate sweet oil. What we've got left is a lot of dirty crude contaminated with various things. It doesn't come out of the ground very fast, such as Athabasca or Venezuela. It's expensive, and we're going to pay a fortune for it. $5 to $10 is not, it's a bargain, he says. The problem is refineries right now, they're not equipped to handle this type of oil. Peak oil, this is another hearing. Robert Hirsch, Executive Director of Exploration for Atlantic Richfield, now with SAIC, commissioned and did a report for DOE, Hirsch report. Peak oil is not a theory. 33 out of 48 of the largest oil-producing countries have hit peak. It will require more than a decade to transition our civilization away from our heavy dependence on oil. Nothing, let me repeat that, nothing close to the efforts envisioned by them have even begun. We are heavily dependent on oil. The prices are rising rapidly, and we may be at peak already. And in the words of Smokey and the Bandit, we have a long ways to go and a short time to get there. This is a close-to-home example. About 10% of our oil comes from Mexico. The world's second largest field is the supergiant field Darrel. It has now been noticed to be in decline. Mexicans are trying to replace it. They are looking at Cumalubza, forgive the pronunciation, which is a heavy crude field, or also Chicontepec, which has small pockets within fractured oil. They do not have the technology to develop either field. The Mexican Congress says they will not be allowed to procure this technology from American companies. What will happen? Well, your pocketbook will find out. In order to develop Chicontepec, they're going to need 20,000 wells. They haven't drilled that many wells in 70 years. Meanwhile, the world, notably China, is hungry and very quickly growing in oil demand. China passed Japan last year, actually 2004, as the #2 world oil importer. Global demand for oil is surging. China burns more coal than the U.S., which you'll see later impacts our CO2 picture very directly. In the words of the London Times, welcome to the new Cold War. There was a bitter pricing dispute, you may have noticed, in Ukraine recently, in the winter, with Russian gas being interrupted because they couldn't agree on prices in Ukraine. I'm going to kind of hurry on through some of these. We have a great many risks going on in many oil fields around the world which directly impact price. These will probably continue, in fact, intensify. And of course, we are involved with some military efforts to try to secure some continuity and secure peace and so forth. By 2010, estimates are U.S. will import 61% of our oil. All these presentations will be online. You can get them. I would encourage you just to take a look at some of the authorities and experts. The discussions are quite intense these days. Let me tell you that the Energy Information Administration, around 1997, was telling the utility companies, you need to clean up your act, and they were being sued by various northeastern states about their CO2 emissions and other noxious emissions. As a result, they turned to burning natural gas, and the Energy Administration had said that there was 35 billion barrels of oil equivalent gas in Mexico. 5 years later, they changed that estimate to 6 billion barrels of oil equivalent gas, after the utilities had already built something like 200,000 megawatts of natural gas generation capacity, which impacts your cost of natural gas and will continue to impact the price and availability of natural gas. And to shift focus now to CO2, which is increasing from burning of fossil fuels. It is impacting all ecosystems. It's a very slow process, but it's been going on for many years. A recent paper by the Royal Society notes that the ocean pH has risen about 30%. Now, that doesn't mean anything to you and me, probably, but it means a great deal to the calcification process by organisms, including phytoplankton and zooplankton, which are a major source of food for fish and animals that feed on fish.
So the ocean pH moved from 7 to 9?
pH is a log scale.
Oh, the log scale.
It's a log scale. I believe normally it was in history at 8.1. We're now about 8.2. I think you'll find. This is a log scale. They've been measuring, in conjunction with IPCC, how plants are affected if CO2 doubles. And estimates are that CO2 will have doubled around 2050, sometime in the middle of this century. What's going on with our plants? Plant available nitrogen decreases around 40 to 50% under elevated carbon dioxide. What that means is reduced nutrition from foraging grasses growing under double CO2. Ruminants, cattle, sheep, oxen, buffalo, deer. This is how their ability to digest these changed plants changes. They will gain weight more slowly under double CO2. The nutrition they get from those plants declines significantly. You can see the scales there. These from Kansas State University. This is a slow process. It takes years for this to happen, and probably many more years for it to be reversed, if ever. So, nutrition in C3 grains. C3 is a photosynthetic pathway. Wheat and rice are photosynthetic pathway C3. Wheat and rice, top cereal grains in the world, both decline in nutritional value based on testing under elevated CO2. Wheat grown at double CO2 declines by around 9 to 13%. The bread made from this has poor dough consistency, decreased loaf volume. Rice, very similar. The nutritional value of rice was also changed in high CO2 due to a reduction in grain nitrogen and therefore protein concentration. Protein requires nitrogen. Ruminants, for example, have difficulty getting that out because if you know anything about composting, composting requires nitrogen to do rapid composting. Iron and zinc concentrations in rice, important for human nutrition, would also be lower. There are some bright spots, however. Cotton does very well under higher CO2. We'd have lots of cheap t-shirts. So the picture I'm getting at here is it's quite if you're a cotton farmer, you probably won't mind at all. If you're interested in bread for dinner, you may have other viewpoints. Macro global climate change. We're shifting focus now not from the micro level of nutrition, but to the macro level, droughts, floods, severe storms. These are immense problems, and I won't try to suggest that they're anything else other than complex. More importantly, the data is even now struggling to be understood, and NASA and many people thousands of scientists are seeking to model it and better show how these are connected. One of the most important things going on is the Great Ocean Conveyor Belt. The heat collected in the world's oceans follows this path. You'll notice the red is the top warm surface water. The bottom is deep water. Right in here is where hurricanes in the North Atlantic are most frequently increasing. Up here is where the warm water sinks. About 90% of the sinking, which drives the ocean circulation, happens up there as cold Arctic waters push this warm, salty water down. And I'm going back. The Europeans are particularly concerned about this from their perspective because in this paper, which was published late last year, they have found a 30% reduction in the warm currents carrying water from the Gulf Stream. In London, you can grow roses. In New York, you cannot, even though New York is 1,200 kilometers south of London. The reason is the global ocean circulation that carries warm water up there.
Sorry to interrupt.
Yes.
I grew up in New York, people grow roses on.
Do you?
Yes.
Well, it depends on the variety of roses. This is a generalization which I've taken from their slides. From people in
You almost couldn't tell.
I know you're from New York, Seth. So you had you had friends who had roses there? Science last year and one just last month. The number of Category 4 and 5 hurricanes worldwide has doubled over the last 36 or 35 years, though the total number of hurricanes has dropped. The only region in the world experiencing more hurricanes and tropical hurricanes overall is the North Atlantic, where they've become more numerous and longer lasting, especially since 1995. This shift has occurred as global sea surface temperatures have increased over this same period. The insurance companies have taken particular note of this because their models for hurricane damage have just been trashed. Does anybody know what the damage from North Atlantic hurricanes was last year? I'll tell you what the insurance companies say. This is a track of them. It's kind of colorful. It was a record year. We had 28 last year. These are some other anomalies. And it's unquestionably hard to say which ones have a connection to rising CO2 and how they're more impacted. That's why I was focusing on the hurricanes, which they have made a more concrete delineation. Global dimming is another issue. They've measured the loss in sunlight over the last half of the 20th century in the region of 2 to 3% per decade. Depending on which site or a paper you look at, there's some disagreement about how much and where, what region. But there is apparently global dimming has taken place, and some people say it may even be in the process of reversing as they change fuels. In any event, human activities, according to the Council of the American Geophysical Union, human activities are increasingly altering the Earth's climate. Scientific evidence indicates natural influences cannot explain the rapid increase in global near-surface temperatures observed in the second half of the 20th century. Research indicates increased levels of CO2 will remain for hundreds to thousands of years. Scientific research provides a basis for mitigating the harmful effects of global climate change through decreased human influences and technological advancement if they are applied. In 2004, Swiss Re, the second largest insurer, was disturbed with what was going on with the insurance and hurricane at that time. Said the costs of natural disaster were in danger of spiraling out of control. They were feared that within 10 years, those damages could double to $150 billion, hitting insurers with 30 to 40 billion in claims. There's a danger that human intervention will accelerate, as it is, and intensify natural climate change to a point that it will become impossible to adapt our social economic systems in time. The human race can lead itself into this climatic catastrophe, or it can avert it. This is the opinion of Swiss Re. Now, last month, April 2006, Munich Re, the world's largest insurance company, in cooperation with American Re, stated 2005 was marked by record losses from hurricanes in the North Atlantic, insured losses exceeding $83 billion. I don't know if you've toured Katrina area lately, which implies $350 billion in uninsured economic losses, including lost profits and business, far exceeding even what Swiss Re had predicted just the previous year. You can get that report from Munich Re, and you'll find that they are desperately working with scientists to try to reestablish their hurricane damage model. Who's going to be paying for the increased insurance rates? I'll let you answer that. An exercise for the student. So what is this gathering storm going to look like? Production of nutritious food very slowly declining. That's happened in biosphere, by the way. Many agricultural regions are experiencing increasing drought. Water for irrigation is in short supply, like the Ogallala Reservoir in central North America. Fertilizer, essential to maintaining nutritious crops, becomes more expensive as natural gas, electricity rise in cost. Electricity went up 10% in the last 1 year in the U.S. Some high-latitude crop declines are attributed to dimming sunlight. The global ocean circulation has begun slowing, according to new scientist studies and observations, warping climate further. Oil production slowly declines as oil prices are setting record highs against soaring demand, triggering other price increases which are all dependent on oil prices. Friction over declining oil stocks intensifies global oil tensions. This is a crude picture trying to understand what's going on in our world. Again, you'll find references to all this on the Space Solar Power Workshop website. There are some things that you can do, and DOE has identified many of these. You can, of course, carpool, get better cars. You can use microwave ovens. It's more efficient than regular ovens. Go to electrified transportation, as Switzerland did in World War II. There are many small things that will be helpful, and we're undoubtedly going to pursue these now, but none of them are approaching what needs to be done according to studies by DOE. Wind power, hydro, geothermal. You can find out about your database for renewable energy. Most states, CO2 is not going to be impacted at all by any of these according to EIA forecasts. The efforts are ineffectual. The problem is just too large. Nuclear power, and I'm going to rip through some of these. Nuclear proliferation, unless we can go to Iran and say that we have, in fact, a real alternative baseload energy generation system, such as space solar power, you cannot tell them they will not be able to pursue nuclear power. This is nuclear proliferation, which will take place increasingly unless we have a solution, unless we're beginning to work on it swiftly. Personally, I would prefer using that great nuclear power plant 93 million miles away. Nuclear waste problems, nuclear fuel supply worries, nuclear proliferation problems evaporate. SSP requires no fuel. It's available 99% of the year at GSO, whereas a typical nuclear or coal plant is available about 90% of the time. That's what we'd like to build. If we started now, could we build it in time? It's a good question. No company is prepared to assume the risks or costs of doing this. I speak because I was in the electric power industry for 12 years doing this. They're almost prohibited by the public service commissions from getting involved in this. As a citizen, you probably would scream if the utilities in California tried to build a space power station. I would. It's simply too large and too risky for someone with those small assets to undertake. There is, however, a tried and true vehicle, and we're going to talk about this in depth at my next paper, which will be at the end of this session, how to build space solar power. That would be a congressionally chartered corporation, just like ComSat. We call it Sunset Corporation. You would do the same thing as ComSat built communication satellites. Sunset would build power satellites. Simple idea. So let's roll. And you can write your congressman. There's a copy of the proposed legislation on the website, and I can give you a flyer if you like. Any questions? Yes, sir, Alex.
Just one quick one. The need in 20 to 30 years from now, it's about 10 terawatt year of energy. Converting it to terawatt peaks probably, since you won't get the whole sunlight all the time, it will maybe, let's say, double that. Now 20 terawatts, that represents times $3, the cheapest terawatt per watt you can buy from solar cell, $60 trillion. Who can support a project of this magnitude?
Nobody's going to come up with that in one lump sum. However, you have been doing this slowly for years. Right?
Right, I guess my comment is that our ambitions are maybe not big enough. We should go for we should call for gigawatt, go for the terawatt. That's the problem.
It's going to take a while, right? Smoking the bandits, we have a long ways to go. We're ready to get on our horse and ride. Thank you.